You've spent half an hour curating an online shopping cart. You're ready to check out, and then the laptop cord gets snagged. Everything goes dark. You reboot the machine, open your browser, and brace yourself to start over. But your shopping cart is fully intact. Every item is exactly where you left it. If your computer completely lost power and severed its connection to the website, how does the remote server still know who you are and what you wanted to buy? Answering that requires stripping away the polished user interface we click on every day and exposing the hidden physical architecture of global communication. This illustrates the physical infrastructure called the Internet. It's a hardware layer, a global network of cables, fiber optics, routing tables, and servers keeping systems online. The World Wide Web is the application layer, the collection of web pages and websites accessed using that physical infrastructure. Think of the Internet as a global system of concrete highways. The World Wide Web is the collection of shops and libraries built alongside those roads. Because the hardware delivery system is separate from the software display, a user can access the same universal pool of information on any device. To navigate that information, you use a web browser. This application is your primary interface, responsible for managing multiple tabs, recording history, and storing the cookies that track your activity. This graphic breaks down a Uniform Resource Locator, or URL. It is a text-based address that can contain the protocol, the domain name, and the specific web page or file name. These text addresses are readable for humans, but web servers route traffic using numerical IP addresses. This chart shows the browser sending the domain name to a domain name server, or DNS. The DNS acts as a directory, looking up the text and returning the numerical IP address required to locate the web server. Without this instantaneous translation, web browsing would require us to memorize a complex string of numbers for every site we wanted to visit. With the correct IP address, the browser sends a request to the web server. Data moves via HTTP, or Hypertext Transfer Protocol, the rules for moving packets from server to device. Most modern requests use HTTPS. Encryption encapsulates the request in a secure layer, preventing data from being intercepted during transit. When data arrives, the browser renders the raw hypertext markup language, the HTML code, into the visual layout, images, and text seen on your screen. However, HTTP is a stateless protocol. By design, the moment the server finishes delivering the HTML, it instantly closes the connection and retains no memory of the user, leading back to our initial mystery. This diagram illustrates the use of cookies. These are tiny, unique text files generated by the web server and stored within your browser's internal storage. These files perform specific functions. They store login credentials, track your individual preferences, and hold items in an online shopping cart as you move between pages. Session cookies provide the web with a short-term memory. They keep you logged in while navigating, but are deleted when the browser closes. Persistent cookies are assigned an expiration date, remaining across multiple sessions. This is how the server identifies your abandoned shopping cart, even after a full reboot. By storing these small files, a disjointed network of isolated page requests is transformed into a continuous, personalized experience for the user. Reviewing the macro infrastructure, the physical hardware of the Internet supports the software-based World Wide Web. To find a site, the browser uses the DNS to translate a text URL into a machine-readable IP address. The server then securely transmits HTML layout data back to the user's device via the HTTPS protocol. Finally, the browser stores session and persistent cookies to maintain the user's state and identity across the session. Every seamless interaction online relies on this specific layered sequence of protocols, executing in milliseconds to turn disconnected data into a reliable global network.